Mainly, there are uh, 5 pins that you want to know. So that is, if this is op amp, this is a side and plus, minus, and output. So this is inverting input, and this is non-inverting input, and the last one is the output, and there are two voltages, V plus and V minus, no matter. So these are the uh, pins that we can see in an operational amplifier. So actually, when you are using an operational amplifier in your calculation or problem that you just only want to need these 5 pins. Okay, let's this now we recognize what is a op amp. Then let's go on to the next part. Okay, normally in our programs that we are using ideal op amps and real op amps both. But in our real world, that we can only see the practical op amps. So let's identify what are these practical op amps and ideal op amps, and there we want to know what are the differences between them. Okay. So wait, I do. So you can see the pins that I have discussed here. So this is inverting input, non-inverting input, supply voltages, and the output. So you just need to draw a triangle. Amps and ideal op amps. No need to draw anything other than a triangle because these circuits are not worth for you, but you should know there is a circuit inside it. Okay. Then normally by a op amp, let's take this inverting input is V1 and this non-inverting input is V2. So by a operation amplifier, it always multiply the difference between these inputs and gives as the output. So it's mean, so you can see this is a plus one and this is the minus input. This is plus input and minus input. So therefore, the different gates V2 minus V1. So you can see V2 is given into the non-inverting input and V1 is given to the inverting input. So therefore, it's V2 minus V1. And it will be amplified by its gain and gives the output. So normally by this equation we can write the gain as V naught over V2 minus V1. So therefore, in a normal operational amplifier, the gain is, sorry, in an ideal operation amplifier, the gain is minus infinity. But in practical scenario, this gain is about 10 to the minus 10 to the power 8. And the RI means it is the resistance or the impedance of the inputs. So you can see in the ideal op amps, the input resistance is infinite. So in a conductor, if the input resistance is infinity, so let's see, V equal IR. So there, if R is equal uh, sorry, the I is equal V over R. So if the R is infinite, that you can say the I is 0. So therefore, like that, if the input resistance is infinite, then this current flows to the op amp is 0. I'm just discussing about the ideal mode. And also the resistance of the output. That means here, the current flows out from the op amps. So it can be any value because you can see the resistance of the output is 0. And normally there are two frequencies called FL and FH. So these are lower and higher cutoff frequencies. Yeah, it is depend to the op amps frequency response. So that's mean normally an ideal op amp can works between 0 to infinite hertz of the feeding signal. But in practical op amps, the gain is not infinite. It's about minus 10 to the power 8. And normally, that in ideal op amp, this is the input impedance of uh, these terminals are infinite. But here in a practical scenario, it is about 10 to the power 12. And R naught is not 0. It's just slight higher than 0. And the cutoff frequencies are also not been between 0 and infinite like ideal of amps. It's about 0.001 hertz and 10 to the power 10 hertz. Uh, so these are the things that you should know, especially you should know about the ideal of amps, these conditions. Uh, so in your problems that you can use these conditions. Actually, this is for the word the gain is given for open loop. Let's discuss what is open loop and closed loop in advance. But now just you should know this is open loop. This is gain is for a open loop op amp. Okay. Now let's move to the next part. So raise your hand if you have no idea about this and if you do not get anything about the operation amplifier. So these are the basic things. මේ කියපු දේවල් පොඩ්ඩක් තේරිච්ච නැති කට්ටිය ඉන්නවනම් කියන්න. හරි. එහෙනම් අපි ඊළඟ පාඩයට යමු. So these are three golden rules relating to operation of plants. So these golden rules means we are using these rules in our problems. So you must know about these things. The first one is operation amplifier has infinite open loop gain. So I told you that in last one G is minus infinity. So this is for open loop gain. And these two are very important in closed loop as well as open loop. But normally we will get problems of closed loop. So as I told you, the no currents, the second rule, it's no current flows into the operation amplifier. So that means there is no input currents from these two terminals. This is the second golden rule of the op amp. And the last one is with a negative feedback. That means close, yes, for closed loop, that normally we connect this in a, when we are giving the negative feedback, we connect this output side to the negative terminal through a feedback resistor. So if a negative feedback is connected, the op amp tries to keep the voltage between these two terminals equal. So that's mean the voltage at the non-inverting input and the voltage at the inverting inputs always equal when there is a negative feedback. These are the three op amp golden rules. So especially, so now you can write down these things, note down these things, because these two are very essential when you are when you want to solve the problems relating to op amps. So okay, you can note down, and if there is any problem that you can ask. No infinite gain, no current flows into the op amp, and the voltage at inverting, non-inverting terminals is equal. That case that you should know there must be a negative feedback. These are the 3 points, 3 key points that you should know. These are considered as the op amp's golden rules. Okay. Then the next part is the concepts of virtual lab. So now uh, with the negative feedback, this op amp is always try to keep these two uh, voltages at the voltage at the input voltage of the inverting input and the voltage of the uninverting input is try to keep the voltages always same. So therefore, if one of the one of any terminal connected to the earth, now as these are trying to keep the same voltage, though these two are not connected physically, but this one also is working as it's connected to the earth. So what is the voltage of the terminal if it is connected to earth? Earth කරොත් voltage එක කීයද? ඔය උත්තර දෙන්න. Yes, 0. So therefore, when earth it will be 0, and when it's 0, the other one also will get 0. So this is the virtual earth. So these two terminals are not connected physically, but if one terminal is earth, the other one also uh, behaving as it is connected to earth. So this is the concept of virtual earth. Uh, and in our problems that we are using this concept, but no matter now, always you have to keep the voltage in between these two terminals are equal. So that's the main thing. Okay, let's move to the next one. So that means what are the types of op amps that we can see? So normally in almost all the cases that we are using this voltage out, voltage in op amps. So that means the gain is given V out. The gain is given by the ratio V out or V in. That means delta V in mean now you know the amplifier, the gain is given by multiplying the difference between the input terminals. And in this one, the gain is given by the currents. So therefore, in the current type of amp, that's gain is given by the current out over current in. And there are another two types, trans resistance and trans conduction. Trans conduction. So according to the current input, it gives a voltage out, and in transconduction, it gives a current out according to a voltage input. So normally you can remember this one because this resistance, trans resistance. So you know the term V equal IR. So therefore resistance you can get V over I. So therefore you can see voltage out though in all the terms. On the numerator it is out, and the denominator it is about the input term, and in a trans resistant it is voltage out is at the numerator and the current in and in the denominator, and in the trans conduction it is the reciprocal of the trans resistor. Actually this one is I have given you to remember. Actually these are not the things that we should practice, because normally the op amps are not work. The op amp is not works according to the V equal IR rule, because normally V equal IR we can apply for the ohmic components, ohmic conductors, but this is a non-ohmic component. So therefore, we cannot apply the Ohm's law, but the connectors and connecting wires which are connected externally to these op amps, that we can use the Ohm's law. When you are doing your problems. Okay, now these are the four types, and you must know you should know about these four types, but this is the most commonly used op amps, especially in our applications. Okay, let's move to the next part. Now I have given you all the basics about the op amp. ප්‍රශ්නයක් අහලා තියෙනවා non invert input එක කියන්නේ මොකක්ද කියලා. non invert input කියන්නේ invert කියන්නේ මේවනේ දැන් invert වෙනවා කියන්නේ අනිත් පැත්ත හැරෙනවා වගේ අදහසක් නේ තියෙන්නේ. එතකොට දැන් අපි සාමාන්‍යයෙන් කියන්නේ හරි. දැන් මේ ඉන්වර්ටිං ඇම්ප්ලිෆයර් එකට අදාළ නෙමෙයි කියන්නේ. නෑ ඒකට කිව්වත් කමක් නෑ. හරි අවුලක් නෑ. අපි දැන් ඔප් ඇම්ප් එක ගත්ත කියන්නකො. එතකොට මේක අපි හිතමු non inverting input එක, මේක inverting input එක කියලා ගන්නකො. එතකොට මෙයා V1 කියලා අරගන්නවා, මෙයා V2 කියලා ගන්නවා, අපි මෙයාට Vout එකක් දෙනවා. So normally අපි හරි V1 එක 0 කරලා V2 වලට V0 කියලා V0 නෙමෙයි අපි ගමුකෝ V2 වලට V කියලා වෝල්ටේජ් එක දුන්නා කියලා හිතන්නකෝ. එහෙනම් අවුට්පුට් එකෙන් එන්නේ මොකද්ද? මේ දෙන්නගේ ඩිෆරන්ස් එක. ඒතර මේ දෙන්නගේ ඩිෆරන්ස් එක ගේන් එකෙන් වැඩිලා. අපි ගේන් එකත් එකයි කියලා හිතමුකෝ මේකේ. එහෙනම් මේ දෙන්නගේ වෝල්ටේජ් ඩිෆරන්ස් එක V. හැබැයි V2 ඉන්වර්ටින් ඉන්පුට් එක තමයි වැඩි. ඒ කියන්නේ V අගයක් දීලා තින්නේ ඒකනේ. එතකොට output එක මොකද්ද? inverting minus V. හැබැයි මේකෙදි V2 0 කරලා V1 V කියලා අගයක් දුන්නොත් අපිට කියන්න පුළුවන් මෙයාගේ output එක non inverting. අනිත් පැත්ත හැරෙන්නේ නැහැ. එහෙනම් කෙලින්ම V දුන්නොත් V ම තමයි එන්නේ. Okay, Patim, did you get that idea? Yes. Please raise your hand if there are Tamil student. Okay. Yes. There are some students that I have explained this in Sinhala, but if you need any clarification, please let me know. So okay. And okay. Please take 1 minute and every one of you rename your login devices with your index number as well as with your name that you are commonly used. ඔයාලා සාමාන්‍යයෙන් use කරන නම දාලා index number එකත් එක්ක rename කරන්නකො. Okay. Now I can ask the questions. So and let's see who are not rename their index number set. So okay, 22 TEE 1108. Please unmute your microphone. TEE 1108. Hi there, can you hear me? ඕනේ. So okay, it's the T1077. Okay, those systems are not just log in and they are doing their work, so okay, no matter. Okay, so Yasundu, tell me what are the what are the golden rules of the op amps? So just give me one answer.
Op-amp has a infinite open loop gain.
Infinite open loop gain.
Yes.
Then Nadul, tell me another one. there are another two uh, main golden rules that I told you that you want to uh, you want them to use in the problems. So therefore, what's the second one? Nadul. So Nadul is not there. And okay, anyone of you can unmute and tell me the other two golden rules. ඉතුරු දෙක එකක් හරි කියන්න no matter in Sinhala or English, Indian language that you can give the answers. And uh, mm, okay, one has unmute. Okay, any one of you, a volunteer, can give the answer.
No current flow into the open op-amp.
Yes. AMAP. Yes. Good. No current flows into the taps. Correct. Another one. The voltage between these two terminals are zero. That means the voltage in the input, inverting input and the non-inverting input are equal. So these are the two rules that we are using when we are using the amplifiers in our applications. So this is the inverting amplifier. So you can see what there is a negative feedback in the way we are making amplifier in by the op amps that we are connecting a negative feedback. So this is the V in, that V in, the difference between the voltage input voltage terminals, and therefore and here is the V out. V out is the voltage that we can get from here, and inverting amplifier, you can see the negative feedback, and the input is given in from which? Minus 1. It is inverting input. Inverting input terminal. The third one is, you can see the non-inverting input is grounded. Okay. Now you should unmute your mics. Then cut your mic unmute කරලා කතා කරන්න. So tell me what is the voltage in this voltage here? And you can refer the circuit. මේ තියෙන inverting amplifier එකක්. So amplifiers ජාති ගොඩක් තියෙනවා. අපි අන්තිමට ඒ මොනවද කියලා අපි කතා කරන ටික බලමු. දැන් මේ පළවෙනි එක inverting amplifier එක. So what is the voltage here? So tell me what is the voltage here? So you can unmute your mic and speak. I get some answers through the chat box, but it is not comfortable to you also to giving the answers in the chat box, because when I open the chat box, that there are is a black box that you can appear on your screen. So therefore, please unmute your mic and speaks. So I got the correct answers. Here the voltage is 0. And if it's the voltage here is 0, then what can you tell the voltage here? What's the voltage? It's 0 voltage. And here you get the voltage 0. And as the difference between these two terminals are V in, the voltage here we can consider as V. And as the difference between these two terminals are V out, the voltage in the here V out in the output terminal. So according to the second golden rule, you know, as there is no input current from this terminal to the op amp, so that means the no any current flows towards the op amp. So this I1 current comes through this resistor and I1, and it do not flows in this direction. So the I1 totally goes in this path. And this is by the second golden rule. මේක හරියට golden rules පාවිච්චි කරන විදිය බලා ගන්න. මොකද ඊළඟ එක ඔයාලට තනියම කරන්න දෙන්නේ. And if you have a problem that you can ask. And the next one is from the third golden rule. Now you know what is the voltage of this terminal. මේ terminal එක කිය. උත්සාහ දෙන්නකෝ. ඒක මං ඉන්නවා. What is the voltage of this terminal?
0.
Yes, it's 0. So then what can you tell the voltage here? By the third golden rule.
Zero.
0. Yes. Now to obtain this answer, you can use the Ohm's law, apply the Ohm's law to these two resistors, R1 and R2. It's very easy to know. So that's mean the current flows, and as the op amps is not ohmic device, so you cannot use the Ohm's law to this op amp, but as the inverting amplifier has two resistors and they are their behavior is according to the Ohm's law. So therefore you can use the Ohm's law to this R1 and R2. So let's see how we can do this. So here now we are applying V equals IR to the R1. So the voltage in the two ends of this R1 is the current flows from this end to this end. So that means V in is higher than this voltage. So therefore R1 V in minus 0 is equal to the current flows through it is I1 R1. So by that you can get V in is equal I1 R1. So the first one. And applying the Ohm's law to the resistance R2. So voltage in at the two ends are 0 and V out, and you can see the current flows in this direction. So therefore the 0 is greater than V out. So therefore 0 minus V out is equal to the current through this is I1 and I1 R2. And you get the second equation as V out minus I1 R2. This is the second equation. And now you can divide second equation from the first equation, and you get V out over V in is equal to minus I1 R2 over I1 R1. So you can cancel out this one, and finally you get V out over V in. That means this is the gain. This is the gain. So gain, you get V out over V in. Output එක input එක වගේ key ගුණයක්. So you get the out with respect to V in, and that ratio it's given by minus R2 over R1 minus R2 over R1. So therefore, now you can understand how you can find the gain of this inverting amplifier. Okay, so you can note down this one, and please be aware of this and understand this thing, because the next part you should do yourself. So therefore, please try to understand and note down these things. And if there is any confusion, you can unmute your mic and ask from me. Okay, note down these things. Okay, now I think you could understand what is inverting amplifier. And let's move on to the next part. It's non-inverting amplifier. So now you know the two op-amp golden rules, and as well as you can see the circuit of op-amp golden rule, and here these two terminals are not connected. So that means one is going over the other one, and this is also have a negative feedback. You can see here the negative feedback. And you can see this non-inverting inputs has not connected to any terminal. It just giving an input voltage. So you can identify the current path is flowing in this direction. The current path from here I and goes to here because it does not enter in from this terminal to the op-amp. So therefore the current flows in this path. And now you can apply two golden rules and may apply the Ohm's law to this R1 and R2 resistors and obtain the voltage gain of non-inverting amplifier. Non-inverting amplifier voltage gain එක දැන් ඔයාලට හොයන්න තියෙනවා. So now you can start. Or if you have confusion that you can ask, and as well as if you want to know anything about this non-inverting amplifier, please raise your hand and ask questions. And I will continue the rest after you finding the voltage gain and proving the voltage gain of this non-inverting amplifier is 1 plus R2 over R1. Okay, have anyone of you mm, obtained this voltage gain? And you should know. Okay, let's start. The voltage here, this is grounded as this is 0 volt, and here sun is 0 volt, and this one is also 0 volt. Then as the difference is V in, here V in, and this difference is V out, so this is V out. And then the voltage is V in to the non-inverting input, and therefore you know these two voltages are equal, so the voltage at X is also V in. So now we can apply V equal IR to these two resistors. For the R1, it is you can see the voltage, so the current flows from this direction. So therefore here 0 minus V in is equal to I, this IR1. So this is the first one. And the second one is R2. From V in, the voltage towards the V out. V in minus V out. So it is IR2. So therefore, by these two equations that you can, by 1 and 2, you can rearrange the equations and get this answer. So you have to try it, because otherwise I'm not going to give you all the things and all the proving. So therefore, you should obtain the voltage gain, and you can see the voltage gain, that means the V out with respect to the V in is 1 plus R2 over R1. It is the voltage gain of non-inverting amplifier. So now you can see here the voltage gain is minus R2 over R1. So you know resistors, they are always positive. So therefore this is a positive value. But in the inverting amplifier, you can see the voltage is amplified, being amplified, but it's changed its direction. So therefore this is called the inverting amplifier. And in this case, you can see R2 and R1 resistors are positive, and it's plus 1. So therefore this is a positive value. So that's mean the direction will not change. So therefore therefore why this is called the non-inverting amplifier. So now you know to work with the inverting amplifier and non-inverting amplifier. So to your exams, you must know about how to do the proving part of this amplifiers. So there are 2-3 more amplifier. So there are more amplifiers that we want to discuss, and in all the case that you should know how to prove the gains of those amplifiers. So okay, it is just easy to remember. because we want to find the ratio of V out to V in. V out එකයි V in එක අතර ratio එක හොයන්න තමයි ඒක තමයි voltage gain එක වෙන්නේ. එතකොට ඉතින් ඒක හොයන්න තමයි තියෙන්නේ. හරි. So I think you have enough time to note down these things. මේක නම් note down කරගන්න තියෙන්නේ. So okay, now let's move on to do some exercise. Okay, please try to determine the gain of these following circuits. So tell me, what is the first one? Is it an inverting amplifier or non-inverting amplifier? පළවෙනි එක non-inverting එකක්ද inverting එකක්ද?
Inverting.
Inverting. You can see because the V in voltage input is to the inverting terminal. So therefore this is inverting amplifier. And this one V into the non-inverting terminal. So therefore this is, as we are giving input to the non-inverting terminal, this is non-inverting amplifier. So you can remember those two equations and you can find the gain. Then gain එක වන equation දෙක අපි කලින් කතා කරා. එහෙනම් ඉතින් equation දෙක use කරලා ඔයාලා දෙන්න බලන්න මේ දෙකේ gains මොනවද කියලා. And after finding the gains, you can keep it in the chat box. Chat box එකට දාන්න වෙනවා. Because in the non-inverting amplifier, you know the V out or V in is R is, that means gain is minus R2 over R1. So therefore you have to identify R2, R2, R2 is the RF. This is for 5 kilo ohm, and the R1 is 10 kilo ohm. So therefore you can get the answer. You can cancel out K and get the answer as 0.5. But it should be minus because it's a inverting amplifier. You know, in the inverting amplifier, there's a minus sign. And in the non-inverting amplifier, so the voltage gain is V out over V in is equal 1 plus R2 over R1. So therefore the answer is 1 plus R2 is 5 over R1 is 10. So therefore the answer is 1.5 units. So this is how you can find the two gains. Okay, I saw that many of you have obtained these answers, and it's good. And let's see. So raise your hand if you have any question obtaining these answers. So it seems no one have any question. So it's good. Then let's move on to the next part. And there you can see an example. Before that one, I like to introduce you about the supply voltage. So now you know that you can have the voltage gain, and here these are the supply voltages. So that's mean this voltage out. So now you know the gain. You can get the gain as V out over V in. That means V 1 if we get V2 in V2 minus V1. So this is the gain. But this voltage output V naught. So now by this equation that you know that you can get V naught is equal to G into V2 minus V1. So let's think that we will give a voltage here 1 voltage, and for this one 3 voltage, and let's think the gain is 10. So what should be the output voltage? What is the output voltage? Sorry, the gain is not 10 volt, it's 10. So what should be the output voltage? Gain is 10. And this different is 2 volts. So what is the voltage here? So voltage in the output. Yes, it's 20 volt. So therefore, you should give the answers with the units. So this is 20 volt. But what's happen if you are supplying the voltage plus 15 volts and minus 15 volt? That means if you are supply the supply voltage in between plus 15 volts and minus 15 volts, then this voltage out should in between these two values. But you can see in this case, this 20 volt has exceed this 15 voltage. So no matter whether it is uh, whether no matter this value can be a large value, but the final output value could not exceed this value. So in this case, if we are applying this plus 15 and minus 15 voltage to the as the supply volt, the V out should be plus 15 volts. Got it? Okay. Then tell me what's happened if I apply uh, here 2 volt and here 3 volts. What will be the final V out? In this case, we apply two supply voltage as plus 15 and minus 15. Yes, the answer is 10 volts because the difference is 1 volt and it is gained by 10. So therefore it's 10 volt, and as the supply voltage is between plus 15 and minus 15, that you can obtain this voltage. So that's okay. Please note down the important things. Then you can go to the next part. Okay, I think you have note down these things. Okay, now you can try the first problem. So normally that we consider R in as R1 and the RA feedback resistor is R2. So in the problem, if you can get this as R1 and R2 or RF and Rin. So normally it's better to understand this thing with RF and Rin, because in some cases that R1 and R2 can be given in other directions, but that you should know about the feedback resistor and the input resistor. Okay, try the first example. So what is the voltage gain of the amplifier? Yes, correct. The answer is minus 50. So the gain you can get minus RF over R in. So therefore, it's minus 10,000 over 200. So therefore, the answer is minus 50. And then what is the output voltage? The V in is 0.5. So the output voltage is 0.5 into minus 50. Uh, so I write the answer here. It's 0.5 voltage into minus 50, the gain. So the gain is minus 25 volt. Then you ask what happens if the op-amp supply voltage is plus minus 10 volt. So it means you know that by a supply voltage plus or minus 10 that you cannot provide minus 25 volt. Therefore, the answer is minus 10 volt. So these are the three answers. And raise your hand if you are failed to get the answers. Okay, none of you do not fail to get these answers. So okay, I will share this with you, and there are some more exercises for you. The second one and 3 and 4 example. And then let's move on to what's the comparator. So actually, in a comparator, it indicates which of the two voltage is larger. So now you know, normally in op-amp that you get the voltage out, it's multiplied by gain, and it's from non-inverting input, V plus minus V minus. So therefore, now you know if the non-inverting voltage input is larger than inverting input, so you get V naught as a plus value. And when V minus is larger than, that means the voltage at the inverting input is larger than the voltage at the non-inverting input. So you get the voltage value as a negative value. So therefore, by using this one, we can use the op amp as a comparator. So you can see, so here V1 is the voltage at V2 larger than V1. So V1 is the voltage at inverting input and V2 is the voltage as inverting input. So therefore you can see by this, it's compare the voltages at those two inputs, and whether the non-inverting input is larger, it gives the output will be a plus positive value, and if the non-inverting input is larger, then you get a minus value. So therefore, by using a comparator, that we can use it for that by using a comparator mean that we can use the operational amplifier op amps for as a comparator. So therefore, by using the op amps, that we can compare two voltage of 2 points. So this is how we can use it as a comparator. Uh, okay, let's this is somewhat easy because normally you know that by the op amp that we can compare the voltage, and by the inverting and non-inverting amplifiers we also did that. But here we can directly use the op amp without any negative feedback or external circuits to measure or compare two voltage at 2 points. Okay. So now let's see how we can use this comparator in the circuit. So therefore that you can see this is the temperature switch circuit. That means if the temperature raised, this should gives an alarm, because this is you can consider this as a fire circuit. So let's see how it's works. So before moving into the to discuss about these circuits, please tell me how we can operate this transistor. So now we have learned about the transistors in analog electronics. So how you can switch on this transistor? Transistor switch on වෙන්නේ කොහොමද? Transistor එකක් operation region එකට ගේන්නේ කොහොමද? So you should know that you have to give a base current. So therefore, that's to operate this one. IB should be positive. I consider this as ideal transistor. In those cases that it should be 0.7. like that value. But in this case, so the main thing is that we want to know how the operational amplifier op amps works here. So therefore, the thermistor is a device when the temperature is increased, the resistance decrease. So therefore, okay. So if the supply voltage is V plus and here grounded, and consider this branch. So the voltage here is 0 volt and here V plus. So what is the voltage here? Because you know there is R1 and R2, both are similar value. මෙතන බිඳුව නම් මෙතන V plus නම් මෙතන voltage එක කීයද? So you have to use the voltage dividing rule. Voltage dividing rule එක තියෙනවා. කීයදනේ? දැන් මොකුත් කතා කරන්න තුනේ නෑ. So these are the rules you should know because as you are ET students, that you should be familiar with these things because otherwise the BST students also know these simple cases. So I will do not explain what is the voltage divide rule, and as there are two resistors and the voltage here is V plus over 2. And normally if the resistance R1 is equal to R2, the voltage here also V1 plus R2. Sorry, V plus over R over 2. Then let's see what's happened. In this case, you can see the both voltages are in similar values, so therefore this op amp will not operate. That means do not feed any voltage, positive voltage, so therefore this switch does not work. This transistor does not work, so therefore this switch does not, this relay does not work. But if the temperature increase, you know, the R1 will decrease. So therefore, in this case, according to the voltage dividing rule, the R1 is less than R2. Therefore, the voltage here, let's take this voltage V in. This voltage V in is, yeah, R2 is greater than R1. So V in will be greater than V plus over 2. Because from 0, here this is a great value. So the voltage here will pass this value. So therefore, this will pass the half of the supply voltage. So therefore, the half of the supply voltage is, now you know the V in is higher than this one, the half of the supply voltage. So therefore, in this case, the non-inverting terminal input gets a larger voltage. So therefore, now you know here V plus is V plus is greater than V minus. That means voltage at the non-inverting input is greater than voltage at the inverting input. So therefore, the op-amp passes a current of positive current. So that means V out is larger than 0. So therefore, this operates. So this happens the vice versa also. That means when the temperature decreases, the R1 rises. So therefore, according to that, you can see this op-amp will not work, because on that case, I'm writing it in red, because in this case, when the temperature drops, the resistance R1 will be increases. So in that case, according to this circuit, that you have to obtain this one, the V plus is less than V minus. So therefore, that you have to understand this one like the previous one. So before that, please note down these things. And before studying this comparator, please check whether what is voltage, what is voltage dividing rule. This is very easy concept. By using that one, you can obtain the voltage in these two junctions. Then after that, you can obtain how these comparators are work. Okay. So you can write down. So, and if you have any question, please raise your hand. Okay, this is how we can use the comparator in circuits. And the next part is the voltage follower. So this can be considered as a voltage buffer also. In that case, the voltage follower, we use it to isolate circuits. Or in some case that we can, if we want to isolate the two circuits from, that means the input circuit and output circuit, so we use voltage follower. So by this voltage follower that we can remove the interference or remove the noises also. So these are the two these are two advantages that we can obtain by the voltage follower. One is that I haven't mentioned here. One is that we can isolate the circuit as well as we can remove the noises. And normally, how we can we can design a voltage follower using op amp. So here in this case that you can see here the op amp, and the V in is given from the positive terminal, that means the non-inverting terminal, and the V out we can get it from the output terminal. But in this case, this output is short circuited with non-inverting input. Sorry, with the short circuit with the inverting input. So therefore, you can see the feedback loop is short circuited. So there is no any resistance between these two, and also there is no any current flows into this op amp. So therefore, you can see the V out is the voltage in the output terminals is similar to voltage in this inverting input. So therefore, in this case, when there is a negative feedback, the voltages in between these two terminals are equal. So therefore, if this is V out, the voltage in the inverting input also V out, and also it's similar to the voltage at the non-inverting input. It's also V out. So therefore, you can see V in is equal to V out. So this thing that we have mentioned here. So therefore, that as the V out is similar to V in, the gain is 1. So therefore, that means the voltage out is follows the voltage in. So that's why we call it voltage follower. So normally that voltage follower has the application when the source voltage cannot supply too much current. When the source voltage cannot supply too much current, that we can use the voltage follower. So therefore, that's the current can be given from the external supply. So the voltage supply. So for this one, the pH meter is an example. So pH meter cannot pH meter only can provide a voltage, but it cannot provide a large current. Therefore, by using a voltage follower, we get the voltage from input side to the output side, but with the external circuits that we can have more current without disturbing that input voltage. So this is called the voltage follower. And the next part is differential amplifier. And after that, we have the differentiator, integrator, and the inverting summer. These are the things that we want to discuss. Okay, today I will stop from here. and this from the voltage follower. So there, before coming to the next week, that now you can understand these are some complex, that it seems complex, but actually these are very easy because all of these are following the two op-amp golden rules and the Ohm's law for the external resistors. මේ හැම එකක්ම තියෙන්නේ අර op-amp golden rule දෙකයි මේ op-amp එකට කනෙක්ට් වෙන resistors වලට දාන්න Ohm's law එකයි. ඔය තුන විතරයි ඕන. ඔය තුන බැලුව ඉතින් මේ කිසිම දෙයක් බෑ. ඒක හින්දා අනිවාර්යෙන් ඒ තුන හොඳටම දැනගෙන ඉන්න සහ inverting input inverting amplifier non inverting amplifier කියන දෙක බලාගෙන ඉන්න. So today we have discussed about the op amps, the operation amplifier. So we discuss it is an IC and it's a complex device, but we do not need how it has designed. We do not need to know how it is designed, and in the op amp, see idea how we have compared how the ideal and the real op amp behaves, and then the operational amplifier. There we discuss about the three golden rules, and these two of golden rules are mainly used in our problems. And then the concept of virtual we discussed. So from that case that we proved this two terminals, the voltage of these two input terminals are equal. And then what are the op amps? And after that, we proved how to get the gain of inverting amplifier and the non-inverting amplifier. And there are some exercises, and I will share it with you. And after that, we discussed about the comparator and how comparator is using a temperature switch circuit. And then we discuss what is the voltage follower. In voltage follower, we get the gain as 1. So that means the voltage out follows the voltage in. So these are the things that we have discussed today. So if you have any question, raise your hand or you can ask now. Okay, it seems that you have no question about these things. So then I will end the lecture. So thank you for joining, and we will continue with the differentiators and other amplifiers in the next lecture. So thank you for joining and have a nice day.